There's lots and lots of inbuilt functions in core Python. I just mentioned print as an example. Input you used last week, that's an example of a function. There's lots and lots of these that you've already seen and that you will continue to see. But we can also write our own functions as well. Most programs that you write can and should have functions within your code. Now, to define a function within Python, we use the def command, def, and we specify the name of the function that we want to give it, the inputs to the function, if there are any, the block of code that will represent the function's inner working, and we often need to return an output, but as I say, not always. It's important to stress at this point, when you're thinking about how you design your functions, it's good practice to have a function that does one thing well. Okay, that's an important habit to get into. It's bad practice generally to have a function that does lots and lots of different things all at once. Now, that's not to say you won't have multiple instructions in order to carry out this one thing that you need to do, but it should have a very clear definition of this is a function that will do this, and it should do that one thing well. And that's how you should think about those functions. And if you need something else done in your code, then you should probably think about having a separate function that may then be called after. That improves reusability as well, because it means that you may, in another piece of code, for example, or a different place in that same code, you might need to do that bit again, but not this bit. So you're making it more atomic, and that improves the reusability. So let's look at an example. Let's imagine that we want to write a function that takes two numbers, multiplies them together, and then works out basically whether the result's more than 100 or not. It's a pretty abstract function, but let's say that's what I want it to do. So here we've got the function definition in Python. You can see I've used the def keyword, and then I give the name of my function. I can call it pretty much whatever I like. It needs to start with a lowercase letter. Capital letters at the start are reserved for classes, which you'll come on to next week. But here I give my function the name multiply and check. Again, good practice to try and name your functions so that it captures as succinctly as possible what your function is doing, so that you can easily remember which function you need to use at a glance, and B, to make it easier for other people to understand it as well. So multiply and check is going to be the name of my function here. You'll probably want some verbs in the name of a function. Remember, a function is a doing thing, it does stuff, so they're probably led by verbs. So I've got my name of my function, then I open some standard brackets, and I put in any inputs that I would be expecting. Now, if I'm not expecting any inputs, I still have to open a bracket, but then I would just immediately close it again. But I still have to have the brackets to indicate that it's a function definition. So here I've got that this function will require two inputs. And I've named them here number 1 and number 2. The names don't matter, and they don't, as you'll see later, they don't have to match the things that are being passed in. It's just whatever we call these things here, that's how we'll refer to them in the main body of the function. So the first input we'll refer to as number 1, the second input we'll refer to as number 2. And again, you want to name these things so that it makes sense what they contain or what they represent. So then we have a colon after the brackets, and then we have an indentation. VS Code and other IDs will automatically indent this, or should do. And everything in that indentation is then representative of the function. So all of this stuff is only then run when you call this function, and not at any other point. So this represents what we call the function body. So you can see in the body of this function, what we do is we multiply number 1 by number 2, and we store that in a variable called result. And then we check, using a simple piece of conditional logic, if the result's greater than 100, return true, and else return false. So these are the outputs. This is how we pass back outputs to the main code, if we've got any outputs in our function, we use the return statement. And return basically means hand this back. Okay, so return, and here I'm returning some Boolean values. So I'm either returning the Boolean true or the Boolean false. And remember, the capital T and the capital F indicate these are Boolean values and not a variable called true or false. Also worth pointing out at this stage, you may hear me and others refer to inputs to a function as arguments. It's the same thing. Okay, so if you hear the word argument, it means an input to a function. And I say that quite a lot, so I'll flag that up now. So we've written a function now, we've written our function definition, but as I say, at the moment, Python is just being told this is what this function looks like, but it won't actually do it. It won't actually carry out that code until we tell it. And telling Python that we want that function to run, that we want it to do the things that we've specified in that function, is known as calling the function. Okay, so when you call a function, it means it tells Python, right, go back to that function definition, and I want you to carry out the things that I told you to do when I call this function. Now you can call the function anywhere in the code after the function has been defined. It may seem a rather obvious point, but if you're new to coding, it perhaps isn't. You have to define the function first before you can call it. Remember, even with functions and even with object-oriented programming, the interpreter is still going through line by line and reading these things in. So if you try calling the function before you defined it, it'll say, I don't know what that function is. It hasn't got that far yet. So do bear that in mind. However, once we've defined the function, we can call that function, and we can call it as many times as we like. We can call it once, we can call it 100 times if we like. Now, when we call a function, we have to give the name of the function to say which function that we are calling, but we also have to provide any inputs when we wrote the function definition that we said that we needed. So if you recall on this one, this says it's expecting 2 inputs. Okay, now it doesn't matter that we've named them number 1 and number 2 here. That's just so that we can refer to them as that in the function definition. That's largely regardless, but it's expecting 2 inputs. Okay, and because of the nature of this function, they're going to need to be numerical inputs because we're going to perform a mathematical operation on them. So we have to pass those in when we call the function. And similarly, if our function is passing it out any outputs, if we've got any return statements, which we have here, then we need to capture that output. The function is going to pass it back to us, and we need to store it somewhere. We need to do something with it. And if you don't, it's going to throw up an error. So in this case, we need 2 inputs for our function, and it's going to pass back a value, which it'll be a Boolean value. It'll either be true or false, depending on what gets passed in. So here's an example of that function being called. Here, what I'm doing is I'm getting the user to input 2 different numbers. You saw an example of this kind of thing last week. Get them to input a number and then cast it as an integer. And then I'm going to call this function. So I use the name of the function, then I open my brackets, and it needs 2 inputs. And the 2 inputs I'm going to pass are the 2 numbers that the user input here. So that's user input 1, user input 2. So that's the tick for giving it the inputs that it needs. But because that function will pass back an output, we need to store it somewhere. So we use the assignment operator to do that. So I'm going to store, remember it's going to be a Boolean, it's going to either be true or false that gets passed back from that particular function. So I'm going to store that in a variable that I've called isResult over 100. Okay. And here, if I put isResult over 100 equals, remember equals is the assignment operator, that basically says, let the output of this function be stored in this variable. Okay, so just as you've seen before with variables last week, where we gave a variable name, then equals, and then a value, we're doing the same thing here. It's just that rather than hard coding the value and specifying what it is in the code, Here we're saying call this function, and in doing so, it'll pass you back a value. That value should be stored in this variable. So it'll either be true or false. And then I've got a piece of logic here that I can say, well, if the value that was passed back and stored here, if that's true, then I can print this message.